For nearly a century, Australia has been locked in a quiet, relentless ecological war, one that began with a decision so misguided it would go down as one of the most catastrophic mistakes in wildlife management history. In 1935, faced with devastating crop losses caused by cane beetles, scientists and officials in Queensland turned to what seemed like an elegant biological solution: introduce cane toads, natural insect predators from South America, to control the pest population. A small group of just 101 toads was released into the wild. At the time, it appeared controlled, even promising. But what followed was not balance, it was explosion. The fundamental flaw in the plan became obvious far too late. The beetles lived high on sugarcane stalks, well out of reach of the ground-dwelling toads. The toads never solved the problem they were brought in for. Instead, they discovered something far more consequential: an environment rich with food, free of predators, and perfectly suited to their survival. Australia had unknowingly created ideal conditions for an invasive species to thrive unchecked. And thrive it did. Female cane toads can lay up to 30,000 eggs in a single breeding season, and they can breed multiple times. Without natural predators willing to risk their potent toxin, their numbers didn't just grow, they detonated. Over the decades, the cane toad population surged across northern Australia, forming an expanding invasion front that pushed steadily westward and southward. Initially, their spread was slow, barely noticeable. But evolution had other plans. The toads at the forefront of the invasion began to change. Those that moved faster, traveled farther, and survived longer passed on their traits. Over time, the invasion front became dominated by larger, stronger, longer-legged toads capable of covering vast distances. They were evolving in real time, shaped by the very act of conquest. But the most devastating aspect of their invasion wasn't their speed or numbers, it was their toxicity. Cane toads possess parotoid glands that secrete a powerful toxin capable of shutting down the hearts of predators. Native Australian animals had never encountered anything like it. Snakes, monitor lizards, quolls, even crocodiles, species that had dominated ecosystems for millions of years, fell victim within minutes of a single bite. Entire predator populations collapsed. In some regions, ecosystems that had remained stable for millennia unraveled within just a few years of the toad's arrival. With apex predators gone, prey species surged, insects multiplied unchecked, and ecological balance disintegrated. Australia fought back with everything it had. Mass culling efforts, barriers, chemical deterrents, and experimental programs were deployed over decades. None of it worked. The scale of the invasion was simply too vast. Hundreds of millions of toads spread across a continent cannot be stopped with buckets and manpower. For a long time, it seemed there was no solution. Then, quietly, something unexpected was noticed, not in a laboratory but in the wild. Along the edges of breeding ponds, researchers observed tiny cane toads, freshly metamorphosed and just emerging from the water, being attacked by swarms of native meat ants. What stood out wasn't just the attack, but the outcome. The ants weren't dying. They weren't even slowing down. This was strange. The same toxin that killed large predators had no effect on these insects. The answer lay in biology. The toxin targets the sodium-potassium pumps in the cardiac muscle of vertebrates. But ants don't operate on the same physiological system. Their bodies are fundamentally different. To them, the toxin is largely irrelevant. And unlike larger predators that attempt to swallow prey whole, ants attack in swarms, biting repeatedly across the surface. Each individual ant receives only a minuscule dose, far below any harmful threshold. The cane toad's greatest defense was suddenly meaningless. Even more striking was how poorly the toads performed against this type of threat. Unlike native frogs that had evolved alongside ants and developed rapid escape responses, cane toads relied on stillness and toxin secretion, strategies that failed completely against coordinated insect attacks. When tested, cane toads ranked last in escapability compared to native species. They froze when they should have fled. This vulnerability opened the door to a breakthrough. Researchers realized they didn't need to eliminate adult toads, they needed to target them at their weakest point, the moment they transitioned from water to land. At this stage, called metamorphosis, thousands of tiny toads crowd the muddy edges of ponds, exhausted, slow, and highly vulnerable. This narrow strip of land becomes a bottleneck, a critical moment where survival rates determine the future population. To exploit this, scientists used a surprisingly simple tool: cat food. High in protein, it acts as a powerful attractant for meat ants. By placing bait along pond edges during peak metamorph emergence, they triggered massive ant mobilizations. Within minutes, thousands of ants would swarm the shoreline, creating a concentrated killing zone. The results were staggering. In some cases, over 98% of young toads were eliminated before they could disperse. Entire generations were wiped out at a single pond. The implications were profound. Each juvenile toad removed represents not just one life, but potentially tens of thousands of future offspring. By targeting this single stage in the life cycle, researchers weren't just reducing numbers, they were disrupting the entire growth engine of the invasion. Importantly, this method didn't harm native species. Frogs that had evolved alongside ants escaped easily. The ants themselves were already part of the ecosystem. This wasn't an introduction of something new, it was an amplification of what was already there. Carefully timed, localized, and temporary, the intervention avoided the pitfalls of past ecological mistakes. In areas where this strategy has been applied over multiple seasons, early signs of recovery are emerging. Native predators like quolls and monitor lizards are beginning to return. Ecosystems that had collapsed are showing the first signs of rebuilding. It's not a complete victory. Eradication of cane toads is impossible, but it is a shift. For the first time in decades, the balance is beginning to tilt. What makes this story remarkable is not just the outcome, but the lesson. The solution wasn't high-tech or complex. It didn't come from adding something new to the environment. It came from observing, understanding, and working with the system that was already in place. A tiny insect, overlooked for decades, turned out to be the key. After nearly 90 years, Australia may not have won the war, but it has finally found a way to fight back effectively. And it all began with the realization that sometimes the most powerful solutions are the ones that were there all along, waiting to be noticed.